right, let's move into our inverse tangent tricks. They pop out a lot. Like not knowing your antiderivative of 1 over 1 plus x squared. It might be death in a class like this because inverse tangent pops up a ton. So let's see the tricks. We got 3 problems. They're all kind of challenging, but you have to see them. Once you see them, now you have to be ready to see them again in other contexts and be able to recognize them. So all 3 of these problems that we're about to do, they're all going to turn into an inverse tangent. So now your eyes are there. Let's see if we can't get it. All right, so the antiderivative, the integral. We're going to take the integral of 7 e to the x divided by the quantity of 1 plus e to the 2x. Okay. I've stumped many students. I imagine many calculus teachers have stumped students with this. This is a classic. Because we go through and it's like, well, let's go to the denominator. U is equal to 1 plus e to the 2x. And you take a derivative on it, and you're going to find out that du is equal to 2 e to the 2x dx. There's no 2x's up here. There's only 1 e to the x. So that's not going to work. That's not going to work. Got to try something else, but I told you, it's an inverse tangent. Here we go. E to the 2x. We got to know our exponent rules. This is equal to e to the x all squared. Remember that? You just multiply your exponents together. So once we do that, maybe let's rewrite this real fast. And also, you see that 7 that's sitting up there? Let's yank that out. That's just a coefficient. There we go. There we go. And now the problem's fast. A lot of the toughest problems, they're not long. You just have to see them so far when it comes to u subs. So let's make u e to the x. And we're talking about this one, not both of them. That one. So du is equal to e to the x dx. And dude, that's what we wanted to get rid of. So what are we left with? 7 times. We have the 1 up top because it just canceled out. We get our du over there. We have our 1 plus our u squared. As I was saying, do it the same way every time, and then your teacher's not. Sorry about that. I get excited. So 7 times the antiderivative of 1 over 1 plus u squared. That's 7 inverse tangents of u plus c. Now we just have to replace our u because we started in terms of x's with no bounds. We got to end in terms of x's. So that's e to the x plus c. And I'm leaving the bounds out in a lot of these problems just so we can go through and do more of the problems. I'm pretty certain you can do basic algebra by just plugging numbers in. So don't think that that doesn't pop up a lot. I'm just trying to get you the techniques. All right, let's go to another one. Now this one's pretty fast. You just got to be able to see it. It's an inverse tangent. It's an inverse tangent. And it goes really, really fast once you see it. But do you see it? I'm pausing for a second. See, can you see it? Because right now you try and choose the u, it just goes away. We're not going to have anything. So first off, you see that 5 that's sitting up top? Why don't we yank that out? And here comes the trick. 16x squared. 16x squared. Did you know that's the same thing as 4x all squared? There's an antiderivative rule on these. There's a form that you could read in the back of any book. You look it up on Google. They could show you how these types of problems are always going to turn out. It's a very, very common form. Now that we have it, it's like, come on, man. There's our u. And that's just a linear function, right? 4x, that's a line. So we can, that's a great place to use u. So du is just going to be equal to 4 times dx. Well, we had a 5 up here. All right, so that thing's not canceling out. That's just going to stay there. And so let's divide out our 4. And we can replace our dx now. Right? Replace out that dx. We go back through. We have 5 times the antiderivative of 1 over something squared plus 1. So let's put in our u. And now we're going to replace out our dx with a 1/4 du. But I'm going to cheat and take that 4 to the outside and just put in our du. And there we have it. Antiderivative of 1 over u squared plus 1. It's going to be inverse tangent of u plus c. Now watch this. Disappeared. Oh, the beauty of having a pencil or something that's erasable. 5/4 inverse tangents of 4x plus c. Nailed it. See, these aren't long problems. They're actually pretty short as far as the structure goes. But dude, you don't see them, you don't see them. All right, last one. All right, one more time. We have an inverse tangent problem, but can you see it? Can you see it? Can you see it? Uh-oh. Okay. First step. See that 100? Let's take that thing out. It's noise. I like putting terrible numbers up in the numerator and trying to make you think that it means something, but it doesn't. Tell you right now, this game is called the Completing the Square game. We're going to get the inverse tangent. It's popping. It's going to happen. But how do we get there? I need to take you back to something real quick. Remember this? You remember this. Remember that? That's the general form of a polynomial or a quadratic. And we use that for the quadratic formula to solve for x if that was set equal to 0. So what I want us to do is just focus on the b. We want to focus on the b. For us, it's 14. So we want to complete the square. That's what's happening here. So I just want to take this part, the x squared plus 14x. I'm going to leave the 50 alone. And I want to complete the square. What number would make this x plus something all squared? To where it's just all one big old square. And I know I'm jumping past that, but it's not an algebra class. This is a calculus 2 class. So what we would say is our b is equal, skipping steps. Our b is equal to 14, right? That's our b. So here's the game to completing the square. It's very simple. Cut it in half and square it. So cut it in half. That's 7. And then square it. That's 49. But since we have a 50 here, that 50, isn't 50 just 49 plus 1? I'm pretty sure it's just 49 plus 1. That's a perfect square. That's x plus 7 all squared plus 1. We can now replace our denominator. If you're not catching this one 100%, welcome to the club. A lot of people don't. Students groan when they hear this technique. Now we can do a U-sub. This is a pretty mellow U-sub at this point, but if you didn't see it, oh my goodness, that would be tough. So we're going to say u is equal to x plus 7. du is equal to dx. So we go back through and we replace. So it's 100 over 100 squared plus 1. We put in a u. Our dx is du. And our answer is 100 inverse tangents of u plus c. Oh shoot, did I forget to write in my u? After you do enough of these problems, you stop writing u at the end. You're like, why would I write this shit twice? Why would I do that? I swore again. Just put in the x plus 7. Efficiency. Laziness. Call it whatever you want. Just doing so many gosh darn problems that you just save yourself some time. Don't. There it is. Now there's many more tough problems, techniques, algebra stuff that I have not covered. We don't have time. I could make videos for 10 hours and not hit every different trick. It's up to you to do as many problems as you possibly can so you can start catching all the tricks. I just gave you a few of my favorites, some straightforward ones. This one, the inverse tangents, because inverse tangent, one more time, pops up a lot. We got to be good with it. Oh, how you're going to miss this section as we move on. So we're going to move into chapter 6 next, where we do area between curves. We're going to do solids of revolution. Oh my goodness, fun stuff. All right, I'll see you in the next.